Hey guys, today we're going to talk about 9.5 linear regression. You may better know this as line of best fit, but linear regression is, instead of a predicted or kind of like a sketched line of what we think the general scatter plot is doing, it's a more precise calculation where we're actually finding what that true line is going to be in the middle of those dots. So, big thing, I'm going to move around because I want to use this calculator. Linear regression helps describe association using a line that fits the trend. Big thing, correlation does not mean causation. So just because we can find a correlation between two variables doesn't necessarily mean that one variable causes the other one. So we can find a correlation between studying and getting A's on tests, but the fact that you studied is not the only cause, or is not a cause for why you got an A on the test. It could be just you're naturally smart. It could be that you really understand the topic. It could be that your teacher's awesome. So there's a bunch of different factors that play into it. So even though we can find a correlation, we cannot find a causation. When we calculate a correlation in linear regression, we are finding trends in our scatter plot. So we can say that studying, okay, I just kind of talked about that. We say about studying causes correlated with good grades, but not a cause. All right. So this brings us to the line that you're actually going to be using. So this should look fairly familiar, and you should see it from when we talked about slope-intercept form, or what is it? Yeah, slope-intercept form in Algebra 1. So before, the M was your slope, and the B represented your y-intercept. So you can kind of match where the letters are located. So in this case, the A is going to be my slope, and the B is going to be my y-intercept. Okay, so a little bit different of a variable. And I'm going to kind of scroll down and put data in to show you how to put this in the calculator. So I'm going to come back to this interpreting page. So we're trying to find a relationship between the fat grams and the total calories in fast food. So when you're doing this, you go to Stat, you go to Edit, and we're going to put data into L1 and L2. L1 and L2 should always have the same dimensions because you have data for hamburger, for fat, and calories. So we have 9, 13, that's not what that says, 13, 21, and it just takes a little bit slower on the computer, but 21, 30, 31, 31, 34, 25, and hopefully I don't miss any. If you're sitting at home watching this, you're probably like, oh, you missed one. Okay, so I put all my data into L1 for the total fat. And I'm going to put all the data in for L2 for the total calories. All right, and when I get to the end, I should have found that the dimensions are perfectly matched. So if they weren't matched, that means I probably missed a number. So fingers crossed here. And we're good. All right, so all my data is into L1 and L2. I go to Stat again, scroll over to Calc, and I'm going to go to one var stat, so one variable stats, and I'm just kidding, I'm not going there. I'm going to number 4, linear regression. Okay, and when I go to linear regression, it should say L1, L2. If it ever doesn't say it, or if your calculator for some reason has erased the L1 and the L2 bar, what you have to do to change L1 is you can go second, alpha, and that'll change it to like L3. So second 3 will change it to L3. But I'm on L1, so I'm going to change it back to L1. You don't have to type anything for the frequency list or the stored regression equation. You're just calculating. So here, it tells us that the line of regression, and I'm going to write this down because we're going to use this example later, is y equals 11.73, and I usually round to 2 decimal places, plus 193.85. And you will notice here that I'm not seeing an R value. So if I really wanted to find that correlation coefficient, I'd need that R value. So if you don't see the R value, you have to turn your diagnostic on. And just to get there, we go to second 0, and you scroll all the way down. It's in alphabetical order. You scroll all the way down until you see diagnostic on. And once you get there, you press enter, enter again, done. So now when I go to my stat regression line, number 4, it should show me my R value. Okay, so that's kind of how we're going to use the calculator. But again, I'm going to take this screen off because it's a little inconvenient and go back to really talking about what the linear regression lines are telling us. So Let's get this out of here. Bye. All right. So when we have our slope and our y-intercept, we have to be able to interpret that value in context. So let's say that this is talking about TV time, so the amount of time that you watch TV, and this is talking about quiz grades. So I see right here that this is probably a strong negative correlation. I'd say that it is going to be a linear correlation, and it already gave me my linear regression line. So my slope for this one was negative 1.1, and my y-intercept was 14.0. The way that we interpret our slope is as x increases by a factor of 1, what is the, as x is increasing by a factor of 1, what is the y value doing? So if my slope is negative 1.1, and I put that over the value of 1, and remember that slope is your change in y over your change in x, and those little deltas, those little triangles mean change. And again, just kind of to reiterate that Algebra 1 topic, so we'd subtract y2 minus y1 over x2 minus x1. And you won't have to actually do this, but just to see what I'm talking about when I say what change in y and change in x are. So as TV time is increasing by a factor of 1, that's your x value, the quiz grades, in this case they are decreasing because they're going down, it's negative by 1.1 points. So you really want to interpret and you want to use that context to help you interpret. So as TV time increases by 1, and we're always going to use x increasing by a factor of 1. What is that y variable doing? For the y-intercept is what happens when the graph is on the y-axis. So when the x variable, so when TV time is equal to 0, quiz grade is equal to 14. Okay, and I'm using that y-intercept from the equation to tell me what my y-intercept is. So when x is 0, what's y? So slope is as x is increasing by 1, how is y changing? The y-intercept is when x is 0, what's the y doing? Okay, so as we go down here, we already calculated this using the calculator function. So we have our slope and our y-intercept. This one is going to be represented in my L1 and my L2. So that's going to be kind of like total calories are going to be my y. So that's change in L2 over change in L1. So as total fat increases by a factor of 1, total calories increase by 11.73 grams. And if there are units, make sure that you include units in your interpretations. For the y-intercept, when fat equals 0, total calories equals 260. What am I looking at? Equals 193.85. Okay, and that's from the y-intercept from my equation. So we're going to be looking at this again with different examples. There's a bunch of different examples that you're going to be seeing. But the big thing is I'm going to use this one here to help you kind of go for that next couple ones. But if I want to say how many calories when total fat equals 36 grams. So there's no data that supports that 36 grams, so it's not anything like a specific variable or a specific number that I'm looking for, but it's asking me to use my linear regression line to make that prediction to what I think the number of calories are for 36 grams of fat. So 36 grams of fat, that is an x variable. So when you're solving for specific values, you have to know what's your x, what's your y. So in this case, I can plug in 36 into my x and solve for my y to find the total number of calories. And you're just plugging that into your calculator just as it's written. So 11.73 times 36 plus 193. And I put parentheses around the 36 as well. Just anytime I substitute a value, I always do that. So that tells me that that's going to be 616.13 calories. And then on the flip side of it, I could say how many grams of fat. Let's use a prettier color. Ooh. Okay, how many grams of fat is R equal to, let's say, 480 calories. So if I want to know what the X variable is here, I'm plugging in the 480 to the Y. So I would do 480 equals 11.73 times X plus 193.85. Okay, you subtract your Y-intercept on both sides. So 480 minus 193.85, that gives me 286.15 equals 11.73x. Divide by 11.73, divide by 11.73. So this is just kind of like a little bit Algebra 1 throwback. So if you're not feeling good about Algebra 1, it's time to sharpen those skills. So I found that it's 24.4 grams. So not only am I going to be using the scatter plot to find the linear regression line, but then I'm going to go one step further, interpret that linear regression line, and also make predictions about what the expected X and Y values are from that line. So this is kind of like a predicted line of what I think is happening with the overall trend of the data. And of course, if I was to look at a scatter plot that was like all over the place, it's hard to draw a linear regression line. So sometimes we can talk about how the linear regression line is not really the best indicator of what the kind of data is showing. But overall, what you're doing, calculating that linear regression line with a calculator, you can do it also with the TI-30 calculator. It's just, I can show you that in person, or if you want to, shoot me a message or shoot your teacher a message and just kind of ask, how do I plug this into my calculator at home? Anyway, so let us know if you have any questions.